Lesson 24, Solving Decimal Equations. To write decimals as integers, we can multiply by a power of 10. I'm going to tell you, first of all, that this is the way that your book teaches it. So I'm going to show you one example of doing it the way that your book teaches it, but after that, it's just the same as we would anything else. Okay, the regular equations that we've been working with, I want you to solve them the same way. If it's easier for you to get rid of the decimal, that's fine. I'm going to show you an example of how to get rid of it. But you do have a calculator that you are free to use at any point in time. So do not stress yourself out over getting decimals converted to integers because it's not incredibly necessary. Okay, so for example 1, we have two examples here, and I will show you on both of these how we will change it to an integer. They say to multiply it by a power of 10. Well, the way that we determine what it is we look at the coefficient with the variable, and in this case I would read this as 2/10, which means that I can multiply everything here by 2/10. So I'm going to multiply this side, not 2/10, by 10 because that's the place value that it's in, and then I'm going to go over to this side and I'm going to multiply by the exact same thing because what I do to one side I must do to the other. So my 10 would distribute, so 10 times 4 is 40, plus 10 times 2/10 is 2x equals, and then 8.6 times 10 is 86. And we're going to solve this the same way that we normally would. I'm looking at the side that has the variable, which is the left-hand side. And the farthest thing away is 40. It's positive, so I'm going to subtract 40. What I do to one side, I must always do to the other. Cancels. So I have 2x equals 46. And to get x by itself, I must divide by 2. What I do to one side, I must do to the other side. So I'm left with x equals 23. Now if we hadn't changed it to an integer, I would have 4 plus 0.2x, or 2/10x, equals 8.6, or 8 6/10. Same exact process. The left side is the side that has the variable. The farthest thing away is this 4, so I'm going to subtract 4 from both sides. Cancels out. I have 0.2x equals 8.6 minus 4 is 4.6. And then again I have to divide because these are being multiplied, so I have to do the opposite. So I'm going to divide by 0.2. What I do to one side of the equal sign, I must do to the other side. That will cancel out, leave me with x equals, once again, same thing, 23. On B, to convert the coefficient with m, which is 4 here, I have tenths, hundredths, thousandths, so it's 4 thousandths, which means I have to multiply by 1,000 on both sides to convert this one. So I'm going to multiply by 1,000 here. I'm going to multiply by 1,000 over here. So this would leave me with 4m, because I'm distributing it and I'm multiplying. And then on this one, I would have plus 60 equals, and on this one I would have 800. I'm trying to get m by itself. To get m by itself, I'm looking at the side that has m, which is the left side of the equal sign. So the farthest thing away is 60. It's being added. The opposite would be to subtract. So I have 4m equals 740. And to get m by itself, this is being multiplied. The opposite would be to divide. And divide by 4 on both sides. I get m equals 740 divided by 4 equals 185. Again, I can do the exact same thing without changing it to an integer and just work with those decimals. So I'm going to, this is one side, I'm going to work over here. I have 4 thousandths m plus 6 hundredths equals 8 tenths. I'm going to follow the exact same process that I just followed. So on the left hand side is where my variable is at. The farthest thing away from m is this 6 hundredths. So I'm going to subtract 6 hundredths from both sides. Those will cancel. I'm left with 4 thousandths m equals, and if I have 0.8 minus 6 hundredths, that gives me 74 hundredths. And then I'm going to, again, I'm multiplying here, so the opposite would be to divide. So that will cancel, leave me with m equals, again, 185. Exact same answer. Either way, it does not matter. You do not have to change them to integers. If you're more comfortable that way, then feel free to do so. Okay, we can solve using our inverse operations, which is what I would recommend doing, not changing them. So I'm looking at n is my variable here. It's on the left hand side of the equal sign, so I'm only looking at this side. The farthest thing away from n is this 4 tenths. It's being subtracted currently, so the opposite would be to add it. Cancels it out, so I have 3 tenths n equals 6 tenths. And to get n by itself, these are being multiplied. The opposite would be to divide. So I would get n equals 2. Final answer. Same thing down here. This time I want you to pause it and try it on your own paper. On B, we're looking at n being our variable. Again, it's on the left hand side. So n is right here with this negative 2 hundredths. The farthest thing away is 8 tenths. It's being added right now, so the opposite would be to subtract it. So that's what we're going to do. Those will cancel out, leaving me with negative 2 hundredths. N equals, when I subtract, I get a negative 4 tenths. So now what I need to do is get n by itself. And these are being multiplied, so the opposite would be to divide, and I have to take that negative with it. So I'm going to show that. What I do to one side, I must do the exact same thing to the other. So these will cancel, leave me with n equals, I have negative 4 tenths divided by negative 2 hundredths, and that gives me n equals 20. Final answer. Finding a decimal part of a number can be the same as finding a fraction or a percent of a number. Whenever you have a problem like this, I want you to take what they have written in sentence form, and I want you to write it mathematically or algebraically. So I have 71 hundredths. I'm going to write that exactly the way I see it, 71 hundredths. Of, you should know, means to multiply. Of always means to multiply. 80. Is, another word for is would be equals. What number? This is what I don't know. When I don't know what it is, I put a variable, w, x, whatever you want to call it, in. So this is my problem now. And this is very simple because my variable is already by itself, which means all that I have to do is the math. So 71 hundredths times 80 is going to give me 56 and 8 tenths. Is my number, W. The height of an average mandrill, a large species of baboon, is 2.54 centimeters more than 12 times the length of its tail. If the height of the mandrill is 78.74 centimeters, then what is the length of its tail? So, some things that they tell me. The height is 2.54 centimeters more than 12 times the length of its tail. Oops, sorry. So I have 2.54 centimeters more than 12 times the length of its tail. So 2.5 centimeters more than, more than means I'm adding it to this, okay? So I shouldn't have written it like that. I'm adding it. Okay, so this means 12.5 or 2.54 more, okay, than 12 times the length of its tail. So 12 times the length of its tail, I'm going to put 12t. And that is, this is equal to the height, okay, so h. So it says if the height of a mandrill is 78.74 centimeters, I'm going to plug in that 78.74 for h and bring everything else straight down, and now I have a problem for me to solve, and I want you to do that on your own paper. And that will be it for me today. Please make sure that you've taken good notes and that you have completed the problems that you should have worked on your own. I'll see you in class tomorrow.